Good evening, students. Welcome to this video. We're going to cover the guided notes for lesson 1-2, line segments. For this particular lesson, we have two standards. We got GR 5.1. Says that I can identify the steps to constructing a copy, excuse me, of a line segment. We're going to talk about that on the second page. And the connecting benchmark is GR 1.6. I can calculate measures of line segments. So that's what we're going to talk about first. Now, let's start here. First key concept is betweenness of points. So it says that point C, I'm going to be very careful because this camera is very sensitive, but point C is between A and B if and only if A, B, and C are collinear. Now, you guys remember from the first lesson and what we've talked about so far in class, collinear means on the same line. All right, so these are all on the same line. They're giving us the example here to the right. And AC, so this section, I'm going to make it green. Make it a little easier to see, okay. That AC plus CB, so we're going to make this blue. We'll just do this. Equals AB. AB we're going to make green. We're going to do it up here. I'm telling you guys in class, it's easier to see. Oh, geez, I used green twice. Dang it. All right, I'll tell you what. Back up. We're going to use this. We're going to just... Oops, we're going to change this to orange. So we're going to say AC plus CB is going to equal AB. Okay, so the key concept we're going to talk about, excuse me, I'm sorry if I fade away. I'm working between the worksheet and the microphone. So key concept, congruent segments. Now congruence, you see that's a equal sign with a little swirly on top. That's red is congruent to. And they have tick marks. These tick marks are like this. And you guys will notice, and we're going to have colored pencils all over the classroom. But we're gonna use the tick marks are gonna be in sequence like these two. You notice it's just one. Now I made them both orange. I'm gonna make mine in colors. If there were two, I would make them, one is orange, two would be blue. If we had a third, I'd make it green. But anyway, these tick marks are gonna go show us what is in congruence, which congruence means equal. So right here you see AB is 1.7 centimeters. CD is also 1.7 centimeters. And as I've said in class, so equals is numbers and congruence is in shapes. All right, so, and it says here, use a consecutive number of tick marks for each pair of congruent segments in a figure. So like I said, if we had a second, there would be two. All right, let's get down here to the key vocabulary. So for any two real numbers, A and B, we're just using A and B because it could be any number. There is a real number N between A and B such that A is less than N is less than B. This relationship applies to points too on a line, and it's called betweenness of points. And we kind of mentioned it up above. Betweenness of points. So if we had a number line, we'll just say A, B, and N is in the middle. Oops, sorry. If I'm not looking at the screen, I don't see how blurry. I apologize. And I'll try to pause in between points so you guys can pause the video if you need to as far as the catching up the notes. Okay. So what it's saying is there's an infinite number between here, whether it's a number line or it's a line and we have points. It's just basically trying to get you to understand that we can put a point anywhere. As long as you understand that you got this concept, and we can move on. All right, so if two geometric figures have exactly the same shape and size, then they are congruent. Again, remember, congruent means equals. All right, so two segments that have the same measure are going to be called congruent segments. Give me just a moment. I'll move out of the way, and hopefully it'll clear out. I'm going to go ahead and write the next word because, again, my camera's a little particular. Okay, so I'm going to back out slowly. All right, so two segments have the same measure, congruent segments. Constructions, now, again, that's on the back page. These are created without the benefit of measuring tools. You can use a compass, straight edge, string, reflective device, paper folding, or dynamic geometry software to create constructions. If you guys were in class today, we used the compass. We didn't have a straight edge, but we had the protractor. I don't believe we have a reflective device. We may get a string later or do some paper folding, and there's also the software in McGraw-Hill. We'll get some practice. Really, I think what we want to focus on is being able to analyze the steps. So, of course, we're going to have to watch it. We're going to have to do it some. I'm going to... 1 second. Yeah, just making sure the video was going. That happens sometimes. Anyway, excuse me. Just want to make sure we understand. It seems to be a hot topic, so we're going to try to learn that the best we can so we can be ready for the EOC in May. All right, moving down the page. Example 3. Sorry. Let me get... Hello. Come on back. Oop. Sorry. There we go. All right, example 3. Find the value of x and BC. So we're going to find x, and we're also going to find BC if B is between AC. All right, so I'm going to write this a little smaller than I've been writing so I can fit everything on here for you guys. So we're going to draw a line AC, and they say that B is between it. Okay. Now they say that AC, so the whole line, I'm going to write this up above, so from here to the other side is 4x minus 12. I'm going to go ahead and write all this in and then kind of hopefully point it out with different colors. They tell us between A and B is x, so I'm going to make it in blue in between. And between B and C, excuse me, is 2x plus 3. Now, there we go. Hopefully we can. All right, so what we know is the whole line is worth this. And some of you guys are getting confused. Remember, this is the algebra part. I'm gonna show you guys how to set it up. We're solving for x, but don't let this big thing confuse you. It's really just a number. We just have to find out what the number is by using the silliness of the letters. I know you guys hate that, and I apologize, or at least some of you guys. Okay, so to set up this equation, to solve for our variable, which in this case is x, and then we need to solve for BC, so we're going to plug it in here. We're going to take this over here, so AC, that's the whole line, it equals AB plus BC. So it equals this piece plus this piece. You see, by the time if I was to color that in, it would all be colored because it's this plus this. So now we're going to plug in what it told us here. So AC was 4x minus 12. So 4x minus 12 equals AB. So AB was x plus BC. So that was that 2x plus 3. 2x plus 3. Okay? Is everybody with me? So the first thing we're going to do, we got two that have the x that belong to it. So let's combine our like terms. 2x plus 1x, so 2 plus 1 is 3x. The plus 3 over here, we didn't touch it, so let's bring it down. Over here, we didn't touch any of this, so it comes down with us. I'm going to switch to a different color because, again, I think it helps. All right, now, I want my variables on one side and my numbers on the other. I always recommend subtract the smaller variable from the bigger. That way you've got a positive number with your variable. So 3 is smaller than 4, so I'm going to subtract 3x from both sides. Excuse me. Now 3x minus 3x, those cancel out. The 3, he comes down. Here's the equal sign. 4x minus 3x is just x, and then the negative 12 comes down. So we have x minus 12 equals 3. We're going to go ahead, I'm just going to bring it way up here. X minus 12 equals 3. We're going to add the 12 to both sides because, again, we want x on one side and numbers on the other. Negative 12 and positive 12, these cancel out. 3 plus 12 is 15. The x comes down, so x equals 15. Hold on. Come on. Silly camera. Sorry. There. So x equals 15. I apologize. I'm going to talk to the IT guy and get the other camera app going. This is silly. So x equals 15. Now they asked for x, so we've got that part. Now we need to give them BC. BC was 2x plus 3. So BC equals 2x plus 3. This thing's about to break. Oh, goodness. All right, so 2 times, now x up here was 15. So we're plugging in x equals 15. So the x, we replace it. All right, 2 times 15 is 30. Bring the 3 down. So BC equals, let me just do this. We're going to write it right here. BC equals 33. Let me scoot out of the thing easily. So we went 30 plus 3. Dang it. Goodness, this is ridiculous. Sorry. So yeah, 30 plus 3. That's why we get BC equals 33. All right, this check over here. This is for you guys. Please try this out. I will work it out with you, but I really want you to try first. All right, so scooching down the page. I'm gonna set this one up for you, and you guys are gonna do this. So these are my little notes to the side. All right, so I know you guys hate word problems. So I'm gonna do my best to set this up for you and try to give you enough hints for this stuff down here. So, all right, so Daryl's visiting the Space Needle in Seattle, Washington. He knows the total height of the Space Needle is 605 feet. So notice this guy over here goes from the very top to the very bottom. And he told us it was 605. Okay. Whoop. Beep. Okay. Now, the distance from the ground to the observation deck. So I'm going to make it this color. Is 10 feet more than 6 times. Stay with me. Whoop. Okay, so this is 10 feet more. Let's do this. Give me just a second. I'm gonna hopefully help you guys here. All right. So, from the from the observation deck to the ground is 10 feet more than 6 times this green amount, okay? Now, I said in class, and if you guys missed it, about 95 times out of 100, when we have a word problem, and it's this is blah, 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 more than or less than something else, that something else is going to be X. And that's the case in this one. So the distance from the observation deck to the Space Needle is X. So now we can set this up a little better. So like I asked some of you guys in class, what does 10 feet more look like? If you said plus 10, thank you. Yes, 10 feet more would be plus 10. Now, 6 times that. All right, so that amount was X. So 6 times something is just like that, 6x plus 10, right? Okay, so this is this amount, this is that amount, that's the total. Use what we learned up here and tell me, they want to know from the ground to the observation deck. So you're going to find X, and you can either plug it in, so it'd be 6 times whatever X is plus 10, or in this case, because X is this amount, so this amount is technically 605 minus X. So if you find X, you can subtract it from 605, and that'll give you this amount. So I'll take either or. Really, if you get X right, then I can show you the rest, but let me see what you got. All right, down below. So here, this is your problem. We got a piece of wood, so we just have a line. And they want to cut it so that one piece is 5 times longer than the other piece. That may be something like this I talked about up here. There's my hint. So, see what you can do with that. Now we're going to flip over to the back side. So really quick, example 5, find the value of X. So remember at the top of this video, we talked about congruent ticks. So I'm going to make them the same color. It's just one tick. So what that's saying is for both of these, like here, PQ is congruent to QR. So this equals this. It's going to be the same over here. There's your hint. Now, so find the value of X. So in this case, PQ is congruent to PR. PQ is congruent to QR. They have the marks. That also means that PQ is equal to PR. And now you plug in. So PQ is 6x plus 20. PR, now notice this is in parentheses. Normally we're pretty much on this, but it seems like the curriculum's kind of pushing this. So let's make sure we know how to distribute this. So we're going to distribute it here. I'm going to write it in red below before I put it down here. Maybe get in the habit of that. I'm not sure. In the past, the book has been pretty much this, but we'll see how it goes. So we have 2 times, Lord, please stop. So we have 2 times x plus 6. So 2 times x is 2x, and 2 times positive 6 is positive 12. So I'm just going to move my numbers down here. See if I can slowly slide out of the way without maybe it. Okay. So you end up with 6x plus 20 is equal to 2x plus 12. So now let's solve for x, because this is what it's asking for. So 6 is bigger than 2, so I'm going to subtract 2x from both sides. My green is about to go out, so this will be it. These guys cancel. 6x minus 2x is 4x. All right, that's done. So the 20 plus 20 we didn't touch it, and the plus 12 over here. Remember the 2x's are gone. So, oops, 12. So we got 4x plus 20 equals 12. Now we want 4x by itself, so we're gonna subtract 20 from both sides. These cancel. We end up with 4x equals negative, nope, no, 20, I'm sorry, 12 minus 20, that's going to be negative 8. All right, I forgot to do the math. Then we divide both sides by 4. And x equals negative 2. So quick little thing, and I mentioned this in class. Sorry, I'm trying to get it to cooperate with me. Goodness. We can have a negative in our variable. If we plug this in and we get a negative for this measurement, we got a problem, because if you think about, let's say we use a ruler or a tape measure. It doesn't matter what you're measuring, whether it's a piece of paper or a car or your hand or whatever. Nothing's measuring negative. Does that make sense? Hopefully it does. Again, sorry. So over here, check example 5. These two guys are congruent. Go ahead and distribute that 4 first. You know what this means. Set it up just like this guy. And I'm going to scooch up the paper. Now, I forgot to bring my protractor and my compass home. I am sorry, guys. Okay. So, just remember, first you need the needle and the pencil at the same. They need to touch the paper together. Put the needle on one end, the pencil on the other. You're going to come down here and make your arc. Then flip it over and do the same over here. Use your straight edge. And now it tells you up here, they say draw the line below it. But I've done some digging at our example down here, and I've told you guys, draw the line after you make the arcs. Once you do it, it'll be like an arc here and an arc here, and then you put your line through it essentially. We'll work on that in class, so if you're watching this and you miss class or you're just trying to catch up, see me, because I know people don't have protractors and compasses just laying around at the house. Unless your parent's a math teacher, which my kids would tell you, yep. Anyway, number 3. All right, so PQ is given. Arrange the steps for constructing XY so that XY is congruent to PQ. All right, so we're going to imagine that PQ is already drawn on here. Now, we'll tell you guys, and I'm going to remember this in class tomorrow, I goofed. I got 2 of the numbers I gave you backwards. So I'm going to put it correct here, and I'll tell you in class tomorrow what is incorrect. So, rather than, I will show you some key words in here as we go down. I can tell you that adjust is not going to be first, because you're going to have to set something up. So just, look here, we're going to set it up. That's going to be number 1. But adjust wouldn't be first. Now, if we set up our point, then we're going to put the needle on P and adjust it here, number 2, to go to Q. Okay. All right. So the third step, this is where I got you backwards. I told you guys in class to pick a point X, but that's not correct. The first thing we're going to do, so with our needle here and our pencil here, we're going to draw an arc where the end point segment of Y, so it'd be like Y was here. So this is number 3. All right, number 4, now without changing, so we've made one arc. Now we're going to flip it over from here to here. So without changing it, we're going to make the X. First we made the Y, then we made the X. All right. Now here is where I had it backwards. Pick a point X. That's number 5. So you pick a point X on the arc that will be the end point of the new line segment. So now we have the points. That's when you would use a straight edge, or use a ruler or a compass. Draw the line from X to Y. So that's 6. hopefully that makes sense to you guys. Skipping here, obviously we're going to do the practice in class, or we'll have something set up for you, a worksheet, or it may be on McGraw-Hill. But in summary, so if B is between AC, B between, and AC, let's do it like this. Oops, excuse me. All right, so if AC is 25, and it says AB is 12 and a half, so this is 12.5. They want to know what BC is. Now we've been doing addition. In this case, we have the total, and we have one side, so we would subtract our one side from our total. So in this case, BC equals AC minus AB, which is 25 minus 12.5. So BC equals 12.5. All right, number 2, determine if the following statement is true or false. Explain your reasoning. Constructions are created with the use of measuring tools. True or false? This one is false. If you go back to the first page, the third key vocabulary was constructions, and it told us that they are created without the use of measuring tools. All right, at the bottom, little survey, evaluate your understanding. If you understand well, please mark this. If you're somewhat unsure, mark this. And if you're confused and need help, mark this. It helps me. I'm not going to embarrass you or anything like that. I need to know what you know and what you don't so I can help you. Sorry, I'm going to try to get it to focus for a moment. Okay, so you guys have any questions, please reach out to me. Send me a message in Focus or on Teams. And until next time, have a good night.